Good morning everyone, I'm Ann-Nicole Badayos from Group 3 and we will be discussing about geotechnical engineering. So what is geotechnical engineering? From the word itself, geo means earth and technical means having special knowledge. So in this field, engineers have practical and scientific knowledge about earth materials like sand, rocks, and soil. Geotechnical engineering is the science that explains mechanics of soil and rock and its applications to the development of humankind. So it is a branch of civil engineering concerned with the relationship of soil and infrastructures. Soil has many different variety like sand, gravel, silt, clay, and loam. It has different properties and also layers starting from the organic layer, surface soil, subsoil, parent rock, and all the way to bedrock. Soil is extremely important because this is where we place our infrastructures like commercial buildings, residential homes, roads, bridges, dams, and tunnels. All constructions that require the support of soil are included in this field. Engineers don't just start the construction right away from the ground. There must be a connection between them. So how do we build the connection between the ground and the building? You may be familiar with what we call foundations. Foundations are responsible for distributing the load from the building to the ground. Geotechnical engineering deals with the solid investigation and design of proper foundations of earth-related constructions or structures supported by soil or rock. So, to have a general idea about foundations, they are divided into two common types, which are the shallow foundations and deep foundations. Shallow foundations are used for small or light buildings, while deep foundations are used for large or heavy buildings. Shallow foundations are also called spread footing or open footing. So, as you can see, each column has its own footing. And the reason why the footing is larger than the column is to make it easier for the soil to handle the concentrated load being transferred to it from the building, since the load is spread on a much larger area. And usually, columns are connected with a horizontal beam, which is called plinth beam, located here on the ground level. Another shallow foundation is raft foundation or mat foundation, wherein the entire floor slab acts as the foundation. When it comes to deep foundations, one good example is pile, which is a long cylinder of a strong material, such as concrete, that is pushed into the ground until it reaches the rock layer or stronger part of the soil. Again, the deeper the foundations are, the more it is suitable for large and heavy loads. So, how do geotechnical engineers come up with the design for foundations? As I mentioned earlier, soil has properties, and one of the most common that geotechnical engineers use is the safe bearing capacity. Safe bearing capacity is the capacity of the soil to support the loads applied to the ground before it changes shape. So, the overall stability and design of the support and the foundations of the structure is highly dependent on the characteristics of the soil. And if this is not calculated correctly, there's a high chance that the building will fail and cause accidents. So this shows the importance of geotechnical engineering.
This is Lian Belante and I will discuss the importance of geotechnical engineering. Geotechnical engineering is a branch of civil engineering that has developed the past, shaped the present, and will protect the future. Climate change is the main reason why we are currently experiencing so much natural disaster nowadays, and that is why we need to improve and make stronger infrastructure to protect our country and of course the people. That is the responsibility of geotechnical engineers. to make our world sustainable. And here are some of infrastructures in the past that caused disaster because of lack in geotechnical awareness. First is in Paris during year 1777, where it collapsed during that time due to unregulated underground limestone quarries used to build all the iconic white buildings during that time. Another one is the Roman Colosseum, which was built on top of an unstable clay layer. Then in the years 1349, an earthquake happened and this Colosseum partially collapsed because, of course, it is lack in geotechnical awareness. But take a look at the Great Pyramids in Egypt that until now is still look exactly as how it is first built before. And the reason for that is not only because of its impressive structural integrity, but also the stability of the foundation. Proper geotechnical awareness is clearly seen in this infrastructure. See how important geotechnical engineer in providing long-term and safe infrastructure in our world. The tasks performed by geotechnical engineers are numerous, in-depth, and paramount to the long-term stability of structure and earthworks. This field is in demand and it is projected to grow even more due to the increasing need of infrastructure and sustainable energies. Humanity relies on geotechnical engineering for resilient structure, efficient transportation, and groundbreaking innovation.
Hi, I am Santa Teresa Linea and I am assigned to report the scope of work or duties of geotechnical engineer. We already know that the process of understanding and working with soil, rocks, underground water, site, and structural conditions in relation to a construction project is known as geotechnical engineering. So for the scope of work or duties of geotechnical engineer, they analyze soil properties to design earthworks and foundations for proposed structures, and for the repair of distressed earthworks and structures caused by subsurface conditions. Basically, geotechnical engineers would be expected to spend much of their time in the field and in analysis laboratories. Also, this field is multidisciplinary and they are supposed to have a working knowledge of a variety of engineering fields. The work of geotechnical engineer begins with the collection of soil samples from the project site using bores and test pits. Among other things, the study would assess the ground stress bearing capability and stability. As a geotechnical engineer, they will be required to analyze the result of subsurface investigations and field tests with dedicated software. After research into soil quality and stress-bearing factors, geotechnical engineers must determine weather issues. And based on these findings and assessments, the geotechnical engineer will plan the next step design and construction of foundation and other support structures. Gradually, the entire building will be built and inputs from the geotechnical engineer will be taken into consideration wherever required. In addition, geotechnical engineers also meet with clients for evaluation of projects progress and to discuss important factors such as budget and time constraints by providing a variety of information.
So this is Diane RL. Another responsibility of a geotechnical engineer is to deal with geological hazards or naturally occurring phenomena like landslide, erosion, rock falls, earthquakes, and other naturally occurring events. These geohazards are capable of causing severe damage to civil engineering structures. It also poses threat to life and the environment. Geotechnical engineers seek to prevent or minimize geohazard-based problems. In order to successfully protect these engineering projects that are likely to be threatened by geohazards, they carry out assessments, analysis of natural and artificial systems in urban or coastal zone, and a geologic hazard investigation, which the objective is to develop best possible understanding of the geologic conditions and use that understanding in identifying hazards at the site, and then address the potential risk they present to humans, properties, and the environment. These assessments, analyses, and investigations allow geotechnical engineers to manage and investigate risk presented by these hazards, to propose mitigation measures, and suggest risk or hazard assessments, and provide design recommendation, to develop risk reduction technologies that could help in minimizing catastrophic disasters in urban or coastal zones, and to help them in evaluating the potential impacts of these hazards on the planning, design, and construction phases of a project. And lastly, to increase safety levels in site works.
Careers in geotechnical engineering. 1. Geotechnical engineers figure out the impact that geological formulation may have on construction projects. They prepare and inspect projects involving drilling and exploration. They are also responsible for geological mapping, report writing, site characterization, numerical modeling, and analysis of excavation or supports. 2. Civil engineers conceive, design, build, supervise, operate, construct, and maintain infrastructure projects and systems in public and private sectors, including roads, building, airports, tunnels, dams, bridges, and system of water supply and sewage treatment. Responsibilities also included estimating costs and personnel and materials needs, preparing proposals, establishing completion dates.
3. GIS analysis utilizes geographic information system techniques to provide a better understanding of certain variables in a given geographic location, extracts data from GIS software, and uses varying methods to arrive at results. They also recommend appropriate reactionary strategies in response to GIS analysis. They also provide maps, datasets to clients to supplement analysis. They are knowledgeable of GIS software and technology. In addition, they work in conjunction with CAD drafters and technicians. 4. Land surveyor surveys and investigates land surfaces to a project precise measurement and location of lines, angles, points, areas, and elevations. They also perform project research, boundary calculation, and record accuracy of survey data, notes, and sketches.
Geotechnical engineers are specialist civil engineers who analyze, plan, and construct foundations and support structures. It includes the design of mine subsidence, levee construction or stabilization, foundations, and road-based materials. These professionals use engineering principles and applications to ensure a structure's stability and longevity. A typical geotechnical engineering project begins with a review of project needs to define the required material properties. They work on such projects such as designing tunnels, roadways, retaining walls, and earth dams, as well as helping to create strategies for the cleanup and management of contaminated sites. They also investigate and assess construction sites, conduct lab tests, create design for structures, supervise construction, and write and present reports. Karl von Terzaghi. He was an Austrian mechanical engineer, geotechnical engineer, and geologist, and he was also known as the father of soil mechanics and geotechnical engineering. So, what is the difference between soil mechanics and geotechnical engineering? Soil mechanics mainly deals with soil's microstructure and its properties. Foundation engineering related to design of foundation and pressure distribution deals with engineering properties of soil, while geotechnical engineering is the branch of civil engineering concerned with the engineering behavior of earth materials. So here are the sample work of geotechnical engineer or related project with geotechnical engineer. the Four Seasons Hotel and Leg Mason, Baltimore MD, drilled shaft earth retention system with internal bracing to expose and repair an existing tunnel, self-sinking Kaizen for combined sewage, overflow capture, and treatment. So, how is this project or work is related to geotechnical engineer? So, before the construction can be done, geotechnical engineers need to test the soil to determine what materials are safe to be mixed with it to create the foundation. Ergo, different places will use different materials to use in constructing a building.
Good day everyone, I am Alexandria F. Encarnacion. I am here to present to you a work of geotechnical engineering. What I have for you today is ground penetrating radar. What is a ground penetrating radar? Invented in 1910 by Gottlieb Flamebach and Heinrich Loewe, ground penetrating radar or GPR is a geophysical technique that produces electromagnetic radar pulses to produce image. This is a non-destructive approach that uses electromagnetic waves within the radio spectrum in microwave band, and this also allows us to track the underground structure reflected signals. It can also be used in places such as rock, soil, ice, snow, water, and etc. GPR is very similar to seismic and sonar technology. High-frequency radio waves are used by GPR, usually in 10 MHz to 2.6 GHz range. Electromagnetic energy is released into the ground by GPR transmitter and antenna. It can be mirrored or refracted or dispersed back to the surface when energy meets a buried target or boundary between materials having different permittivities. The variations in the return signal can then be recorded by receiving antenna. The concepts involved are similar to seismology, except the electromagnetic energy is implemented rather than acoustic energy is applied by GPR methods, and energy can be expressed at boundary where electrical properties of the subsurface change rather than mechanical properties of the subsurface, as is the case with seismic energy. The electrical conductivity of the field, the transmitted center frequency, and the radiated power may all restrict the GPR investigation effective depth range. The electromagnetic wave introduced is decreased by changes in electrical conductivity, and hence the penetration depth decreases. Higher frequencies do not reach as far as smaller frequencies due to frequency-dependent fading mechanism. However, better resolution can be offered by higher frequencies. Operating frequency is give and take between resolution and penetration at all times. In ice where penetration depth can exceed several thousand meters, example in Antarctica, at low GPR frequency, the optimum depth of the subsurface penetration is achieved. Instead of conductive, dry sandy soils or large dry materials such as granite, limestone, and concrete appear to be resistive, and the penetration depth may be up to 15 meters or 49 feet. However, penetration can be as little as few centimeters in moist or clay, like soils with materials that have high electrical conductivity. For the highest signal power, ground-penetrating radar antennas are usually in contact with the ground. GPR air-launched antenna may however be used above the ground. In the field of hydrogeophysics, cross-borehole GPR has evolved to be valuable means of determining the existence and the quantity of soil water.
Hello, I'm Jerome Abonio. Eudometer test. The eudometer test is a kind of geotechnical investigation performed in geotechnical engineering that measures a soil's consolidation properties. Eudometer tests are performed by applying different loads to a soil sample and measuring the deformation response. The results from the test are used to predict how a soil in the field will deform in response to a change in effective stress.
Hello, I'm Conrad M. Faustino, and I'm assigned to represent the organization in the field of geotechnical engineering. First, Academy of Geoprofessionals, AGP. AGP was founded in October 2008 by practicing geoprofessional members of Geo Institute and remains a subsidiary of American Society of Civil Engineers, or ASCE. It recognizes engineers who have a special knowledge and experience in the field of geotechnical engineering. Its goals is dedicated to improving the practice, elevating the standards, and advancing the profession of geoprofessional engineering by the creation and ongoing oversight of the voluntary post-licensure specialty certification program for geoprofessional engineers. Second, American Institute of Professional Geologists, or AIPG. AIPG was founded in 1963. It adheres to the principle of professional responsibility and public service and is the only international organization that certifies the competence and ethical conduct of geological scientists in all branches of the science with members employed in industry, government, and academia. It emphasizes competence, integrity, and ethics. It is an advocate for the profession and communicates regularly to federal and state legislators and agencies on matters pertaining to geosciences. Lastly, International Society for Soil Mechanics and Geotechnical Engineering, or ISSMGE. ISSMGE is the preeminent professional body representing the interests and activities of engineers, academics, and contractors all over the world that actively participate in geotechnical engineering. And it aims for the promotion of international cooperation amongst engineers and scientists for the advancements of knowledge in the field of geotechnics and engineering application. That's all, and thank you. And this is the presentation of group number 3.